A very good afternoon to all of you. Today I'm going to explain about the mathematics belongs to engineering for your respective branch, that is called as information technology. Myself Masiddin Khan. Why engineering mathematics required in engineering, or why mathematics required in engineering? Why this maths is called as a engineering mathematics? These are some questions arises by the students. So it is my always motive before I have to teach the exact syllabus or the actual syllabus of mathematics. First I have to introduce the applications of mathematics which you have to use in your core subject as well as in your core respective branch. So always there is a concept arises in is there any difference of mathematics in engineering mathematics? So yes, in pure mathematics you have to learn, or I'm just giving a one simple example. All of you aware about, that is Pythagoras theorem, which belongs to your school standard or in a 9th or 10th standard. That time you learn or a proof, that theorem you proved how the Pythagoras theorem is derived, or 30 60 90 angle or triangle concept you again learn or derived how it is possible. Similarly, in a pure mathematics, a mathematicians learn how this formula exactly derived or how this equation is exactly derived. But in engineering mathematics it is not necessary, because earlier the subject name was applied mathematics or the applications based mathematics. So similarly the engineering mathematics is also have the same meaning, a mathematics which is used in engineering. Such a mathematics are called as a engineering mathematics. So engineering mathematics is not any branch of mathematics. Basically engineering mathematics is a type of set. When I say a set, what is set? Set is a collection of well defined object. Why I use the word well defined? Because it is a clear things. If a person want a mango, then definitely he want to see only mango, not an apple. So just this is a basic example. If I want an applications of transformations, or I want to transform a time domain function to frequency domain, so definitely I want such a kind of transformations. Or I'm giving you just one more example, or a basic example, so you people will understand very well. Why I'm giving example? Because it is always my motive, you must understand why should I learn this mathematics, what are the uses of this mathematics in my actual subject or in core branch subjects. So that's why I just giving example. Suppose whatever I'm teaching in front of you, if you not understand, then when you and your friends are meeting with each other, such times you are saying कि अरे यार कुछ भी पढ़ाते हैं, नहीं समझ में आता है. But when you have to complain my about me, that is my teaching is not understandable for you people. So you, when you have to report to your HOD or your principal, that time you have to form one rules and regulations. Just you have to write a one letter to your HOD and you submit. Then if things are not in your favor, you have to personally meet and you will talk. So this is called as a something different transformations. But when you are delivering such a things, that is कि जो पढ़ाया है वो नहीं समझ में आता है, that time your friend during the conversation with your friends is completely different, but during the conversation with your higher authorities is again different. So these things are called as a transformations. Similarly you have to learn in your syllabus transformations. Now what is engineering mathematics? Now I just mention here applied mathematics and engineering mathematics. This is commonly the same things. Applied means applications based, engineering means mathematics which is used in engineering. Now just draw here recommendations options for applied maths majors. So computer science, technology and media, chemical engineering, aerospace engineering, engineering physics, electrical and computer, mechanical, data analytics and statistics, actuarial or finance options, civil, environmental, architecture, engineering options, even computational engineering or biology and bioinformatics. So this is basically we have to use every field of engineering, or mathematics is always used in every field or each one of engineering field. So I just write it here. Applied mathematics involves the application of mathematics to problems which arise in various areas. The example are science, engineering or other devices areas, and or the development of new or improved methods to meet the challenges of new problems. We applied maths as the application of mathematics to real world problems with the dual goal of explaining observed phenomena and predicting new as yet unobserved phenomena. Therefore, the emphasis is on both the mathematics, example, the development of new methods to meet the challenges of new problems, and the real world problems. Okay. Now, as I earlier told, engineering mathematics is not any branch of mathematics. Yes. So, engineering mathematics is a branch of mathematics which deals with the study of which are applicable only for engineering. Such a mathematics are known as a engineering mathematics. Means what? If I required a calculus then in engineering, then I have to learn a calculus, but calculus is not a simple 1 or 2 chapter. Calculus is a vast, very vast. So if I required to learn only a Fourier integral, then by default I have to take a Fourier integral from the calculus. So my engineering mathematics sets it will be Laplace transform, Fourier transform, etc., etc. So that's why I called as engineering mathematics is not a branch of mathematics. Whatever your core branches or your core subjects required the help of mathematics, only that mathematics we have to use or utilize here. That's why it is called as a engineering mathematics. So try to understand what I have to explain. Now we are moving with the next things want to explain. Just one thing. Now the Laplace transform and the inverse of Laplace transform. Before I have to explain the transformation concept or why these things are required. I already given one basic example of a student's and teacher's life. What is transformations in engineering? So it is very necessary process. I just want to explain one example of time domain and frequency domain, so that your doubt will be clear why the transformation is. Now the best example of a time domain is your traffic signal or road traffic signal, because sometimes a signal have a time limit of 30 seconds, some signals have a 60 seconds. So once the 60 second is over, the red may convert into green and the green may convert into red, or vice versa. So this is a basic example of a time domain functions, because that function works on time domain only. But when I have to give an example of a frequency domain, you must understand what is frequency domain functions. or what are the frequency domain functions. I just observed and I thought which example is suitable for this Laplace transformations or any other transformations. So I observed the basic example is our aerospace, or if you observe, that is, suppose you are travel from Mumbai to Delhi or any other places by flight, and if your flight timing is morning 11 a.m. but due to some problems or some issue the flight timing may be delayed or maybe preponed, or maximum time it is postponed, not a preponed. Why it is preponed? It's because of frequency. If the traffic arises, then definitely we have to delay the flights or a train. Again, the best example is a train. The flights and train signals are depend on frequency domain functions. Once, और I'm just giving a basic things, अगर आगे का ट्रेन ट्रैवल नहीं कर रहा है तो उसके बैक में जो भी ट्रेन है वो ट्रैवल नहीं कर सकता है. It is not possible. Similarly, if 10:50 a.m. flight is Mumbai to Delhi, have to fly, or Mumbai to Goa, have to fly, but due to some problem or some issues that flight delay, then your 11 a.m. flight is maximum chances it will be delayed, because if you have a single runway, then you must have to fly first Mumbai to Goa or earlier flight. So this is just example of a time domain functions and frequency domain functions. Similarly, you can saw that I'm just giving a basic example of your Fountain Hotel. When you travel from Borivali or Vasai, sometime you observe that is the Mumbai side traffic is high and the Thane side traffic is low. So sometime the police constables stop the traffic signals and start delivering the Mumbai side traffic more time as compared to the Thane side. So why? Because the frequency increases, the number of vehicles increases in Mumbai side. But if you totally depend on time domain, the time will come 60 seconds. Sometimes you will get traffic, sometime you will get freeway, but the timing is similar. If it is not depend, if the frequency is increases, the time decreases, it is not defined in your road traffic signal. That's why the flight signals as well as the train signals are defined on frequency domain, because they work on a sensor based. If you observe, or if you travel from a first or second coach in a train, and if you stand near a door, once the first or second coach pass the signals is clearly orange or red. Sometime maximum it is red, because it is a sensor based. The frequency is clear. Once that part is enter that area, it clearly mention that is someone is traveling or something is traveling. So that's why frequency domain is important. Similarly, in security system, the frequency domain is important. That's why whenever we have to convert a time domain functions to frequency domain, we have to use a Laplace transform. And again I am saying that is, if forward is important in mathematics, then backward is necessary in mathematics, because अगर आप आगे जा रहे हो तो पीछे भी आना आपको सीखना है. So these are the important things in mathematics. Try to understand why I am explaining such a concept. So always remember, whenever we have to convert time domain function to frequency domain, you have to use Laplace transform. Similarly, one more transformation is there called as a Fourier transform, which is also we have to convert time domain functions to frequency domain. So if you convert time domain to frequency, you must have to convert frequency to time also. That's why inverse of Laplace transform required. So the Laplace transform can also be used to solve differential equations. Already when I say that is we have to transform a time to frequency domain, so differential equation is mandatory because it is a rate of change of. So it totally depends on time and is used extensively in mechanical engineering, electrical engineering. I am not mentioning as IT engineering, but when you have to learn image processing and video processing, you must understand what is Laplace transform. So we have to use the just basic rules of algebra like partial fractions and all for the solving of numericals. So this is just the what I say that applications of Laplace transform and inverse of Laplace transform. Hope you understand very well. Now the next one is we have to learn complex analysis. Instead of complex analysis, first I have to explain conformal mapping. In day-to-day life, sometimes we map और sometimes we observe like यार ये कितना अच्छा स्ट्रक्चर है, ये अगर मैं अपने हाउस में ये स्ट्रक्चर बनाऊँ तो कैसा लगेगा. Means you have to map yourself or you're mapping your house, that structure to your house, or sometime you people created a tattoo. So whenever we have to map, like if this structures belongs to here, what will be if I draw these structures to at my place or wherever I like I have to draw. If I draw, how it will look. Similarly, I'm just giving a best example of this mapping. All of you saw that is few Hollywood movies, as even in Bollywood, if you saw there is Bahubali as well as a Jurassic Park movie or any other animal, Godzilla's movie, many movies are there. So it looks like a real Jurassic Parks or dinosaurs looks like a real, but actually it is a mapping concept. That object is a very small, but actually the artist or the technical background people want to show that small element as a big element by conformal mapping. So this is just example of image processing and video processing concept. And now I'm coming complex analysis. I just mentioned here, this is my one object which is look like this, because this is my Z plane. Why I said Z plane? When I say Z, Z means a complex number. A complex number is nothing but a real value as well as imaginary value. When I say Z, Z means this is my X variable, this is my Y variable. So when I draw this in a Z plane, it look like this. But when I draw this in W plane, that W planes belongs to U plus IV. What I'm not going to explain what is U and what is V, but U belongs to XY variable and V also belongs to XY variables. So that structures look like this, because here we can see this is, it looks like a rectangle or a square, but here it is something different, or it is again a rectangle but it does not look like the same. So what is complex analysis? What the relationship between conformal mapping and complex analysis? So basically whenever we have to draw anything, the imagination is important, and when we require the imaginations, a complex number is mandatory. So it's mandatory. That's why a complex number stated that Z is equal to X plus IV, a real part as well as imaginary part. But when I have to introduce a complex variable is what? A complex variable is stated that a real variable, a real valued function and imaginary valued functions. Means you also have XY variable and we also have X and Y variables. So that's why Complex analysis and conformal mapping is important even in cryptography. This things is important because we have to just see the design, and if you have to draw the design on real paper or any other objects, the conformal mapping and the complex analysis is mandatory. Hope you understand about the application of complex analysis. Now Fourier series. As I already told, what is Fourier series? Fourier series is whenever we have to convert time domain to frequency domain, or we can clearly define whenever we have to convert a periodic function, a time domain, from time domain to frequency domain, we have to use a Fourier series or Fourier transform. Such transformations are important in image processing and video processing, because instead of time domain, spatial domain, normal image space, frequency domain, or if I say that is, if you understand the cardiometer concept, cardiometer, suppose if a person's heartbeat is running very high, the cardiogram shows a very well or zigzag line. But if a person's heartbeat is stopped, then it clearly shows a straight line. Now I've just explained again the time domain. Time domain is changing over the time, but frequency domain changes over the frequency. As I told, once flight is take off, then only the second one will take off if the runway is a single. I'm just clarify this. If there is multiple runways, then by default maybe they can shift and they can take off from other runways. Similarly, the image processing and video processing, frequency domain, space in which each image value at image position f represents the amount that the intensity values in image, and I vary over a specific distance related to f. That is image and video processing. So please try to understand this concept. Again I am saying that is Fourier series is again time domain to frequency domain. So try to understand the probability. What is probability? Probability does not require any definitions. Probability day to day every person use a probability. Suppose in a family there are 3 members, so by default the foods prepared on the basis of that 3 numbers, and suppose there are more 10 numbers join, or some family some relatives come to his house, so that when we have to prepare food, so that time we have to consider that 10 more people also, and we have to consider total 13, and according to that we have to take the amounts, how much the foods required for preparations. So it is based on probability, because if 3 people required that much amount, so by default 13% required more. So how much? So that things is generated by the using of probability. Or we can say that life is uncertain, we are not sure what the future will bring, but by using probability we can reach near the goals. हम अपने गोल के करीब पहुंच सकते हैं by using a probability. Never give exact reason or exact answer, but probability provide a few justification so that you can reach your goal very near. For example, the market for the new iPhone X might be good with a chance of 60%. That is a probability of 0.6, or not good with a chance of 40%. So by default, if I consider my iPhone will sell this 1 lakh rupees or 1 lakh rupees, but how much probability is there? We have to just think कि चांसेस कितना है मार्केट में, इसका वेटेज कितना है, क्यों मतलब इतने पे अगर बिकेगा. सो दैट टाइम इट इज़ क्लियरिफाई दैट इज़ अ गुड विथ चांस ऑफ 60%. सो दैट्स वाई 40% I have, that is, it is not a good chance. So by probability you can achieve your goals by using, but it is not exactly you can achieve, we can close to the your goal. So please try to understand, never think that is कि probability हमको आ गया तो हम सब कुछ हासिल कर सकें. No, you have this chapter. While teaching this chapter, I will definitely explain the Monty Hall problems. The Monty Hall problems is a very interesting concept. The first one is a very clearly, that is, if there are three doors, one door containing a sports car or sports bike, the two doors containing goats or any garbage. And if you are going to select the sports car's door, then Monty Hall's problem stated that we are not going to open that door, we are going to open the other two doors. So it is a very interesting thing. By swapping the, we can get a more accurate probability, not exact answer. So just try to understand. So probability plays a very important role in a technical field as well as a day-to-day life. So while understanding the concept and the applications you learn, definitely you will enjoy. Now we'll move forward to next part. Thank you all. If any questions arises, you can ask freely or you can comment. Thank you so much. Have a nice day.